Hi everyone, so the first time I recorded this video, the sound did not record, so I am re-recording my voice over this video. So if it seems a little choppy or if it doesn't seem like it's flowing perfectly, that's why. I'm just going to do the best that I can. So 2.1, complex numbers. So we talked about this for a minute in class, but we've seen I before. So I is the little imaginary unit. It represents the square root of -1. I squared, if we square both sides, it's going to undo the square root. So I squared is -1. So we're going to need to know those two things as we work through simplifying problems. We could simplify something like square root -16, split it into square root 16 times square root -1, and that we turn that into 4i. We're going to be writing all of our answers today in standard form, which we call a plus bi, where a is the real part of the number, the bi is the imaginary part. So complex numbers is just the name that we give to every single type of number, real numbers and also imaginary numbers. Okay, the first time I recorded this, I must have talked a little bit longer on this screen because it's not going to the next screen yet. What else can I say here? So the reason these are imaginary is because it really doesn't make sense to take the square root of a negative number. Wonder if it's about to go to the next screen. Okay, here we go. I was just going to say it doesn't make sense to take the square root of a negative, so it's imaginary. So complex numbers in the form of a plus bi. So if b is 0, like the first example, that's a real number. If a is 0, it's a pure imaginary number. And then if like the last example, 1 plus 3i, that's just an imaginary number. Okay, so adding and subtracting. What we want to be careful with here, anytime we see the two sets of parentheses, sometimes students will see that and just think, oh, we have to FOIL here. But really, we need to see that there is a plus sign separating. So the parentheses are there just to show the two different imaginary numbers, but it does not mean to multiply. We're just adding. It's very simple to add and subtract. We're just sort of putting together like terms. We're putting the like parts together. So we can start by putting the real part together. 5 and 3 is 8. And then put the imaginary part together to get 5i. Okay, when we're subtracting the negative sign, the minus sign, we have to distribute that to the elements. Okay, so 2 plus 6i minus 12 plus I. Then we're just going to put the like parts together. So 2 minus 12 is -10. 6i plus I is 7i. Okay, so now we're going to multiply. So we can start by distributing the 7i to the inside of the parentheses. 7i times 2 is just 14i. 7i times -9i is -63. I times I is I squared. So here's where we're going to simplify. The I squared is really equal to -1. So we can write that as 14I plus 63, but then switch the order so that it's actually in standard form, so it's in the form of A plus BI. Okay, here is one where we are going to FOIL. So we've got our two parentheses side by side. There's no plus or minus sign in between. So 5 times 6, the first terms, we'll do the outside terms. We'll do the inside. The last term, -28, I times I is I squared. You can put the outside and inside terms together. So that's going to give us -11i. I squared, again, is equal to -1. All right, so that turns into positive 28, and then we'll just go ahead and add that to the 30, making 58 in front minus 11i. All right, so we want to be careful when we have a problem like this. Remember, the squared does not distribute, so we just want to write it side by side, and then we can FOIL it just like we did in the last problem. Okay, so now we're going to divide. So here we have 2 divided by 3 minus I. The way we're going to divide is we are going to multiply the numerator and denominator by the conjugate of the denominator. So the conjugate is basically the same, so the 3 and the I, but it's the opposite sign. So the first one was minus, so we're going to turn it into plus. And whatever you do to the denominator, we also have to do that to the numerator. So I'm going to add some parentheses there. We're going to go ahead and distribute on the numerator. So we get 6 plus 2i. On our denominator, we're going to FOIL. So we've got 9 plus 3i minus I squared. All right. So the plus 3i minus 3i cancel. So remember that I squared is really -1. So that's going to turn into 9 plus 1 on the denominator, which is 10. All right, then we're going to split. Okay, actually, what did I first do here? So at first I divided everything by 2, so we get 3 plus I over 5. Okay, but to get our answer in standard form, the a plus bi, we want to actually split apart the numerator, keeping our denominator the same, so that we can actually see that a is 3/5, b is 1/5. That's how we want to write our answer. Okay, so here's another division problem. So same thing, we're going to multiply the top and bottom by the conjugate of the denominator. So the 4 and the 2i, but then make it minus, so it's always the opposite sign. Added some parentheses in there, so we're going to FOIL across the top. And then we also have to FOIL across the bottom. What we're going to see when we FOIL on the bottom is the outside and inside terms again will cancel. Okay, so across the top, so it looks like we put the -10i plus 16i together. On the bottom, 16 minus 4 times -1. Oh, and then also on the top, the I squared turns into a -1. So that's really 20 plus 8. So we have 28 plus 6i. On the bottom, that's going to turn into 16 plus 4. So that's 20. All right, then just like we did in the last problem, we'll go ahead and split apart the numerator. So we'll split that into 28 over 20 plus 6 over 20i. And then we can simplify each fraction separately. So the first fraction, they actually have a 4 in common, so that's 7/5. The second fraction just has a 2 in common, so we'll turn that into 3/10. So that's our final answer in the a plus bi form. Okay, last we're going to finish up by doing some simplifying, looking at some situations that involve the square root of a negative. So square root of -27, we can split that into square root 9 times square root 3 times square root -1. Because those three things multiply together to be -27. So square root 9 is really 3. Square root -1 is I. All right, bring down the plus sign. We'll split the second one, very similar. That one can split into square root 16 times square root 3 times square root -1. And so that ends up being 4 root 3i. So now we can actually put these two together. These are like terms, because the square root 3 part is exactly the same. So to put them together, we're just going to add the numbers in front. All right. So we end up with 7 root 3i. Okay, next one. So squared means multiplied by itself. So we can start by actually writing this out side by side. And before we think about FOILing, let's actually rewrite each of these as square root 3i instead of square root -3. And then we'll go ahead and go through and FOIL. So -2 times -2. Outside is -2 root 3i. The inside is also -2 root 3i. And the last term, so root 3 times root 3 is 3. I times I is I squared. All right, so we'll go ahead and put the middle terms together. So just really adding together -2 plus -2 to get -4. At the end there, the I squared is -1. And then, so that's -3, so 4 minus 3 is 1, and then we still have -4 root 3i. Okay, the last one here, let's go ahead and start by rewriting the square root of negative 12 into square root 4 times square root 3 times square root negative 1. All of that's over 48. So that's going to simplify to this. And then we'll go ahead and split apart the numerator, keeping our denominator the same. And then we'll see if we can simplify each part here. So that first part's going to simplify to negative 1/8. The second part will just simplify to 1 over 24. So we can just write it as root 3 over 24, put the I at the end.